Hi everyone, this is a recording for week 6. So just a reminder with regard to your assessment, you're going to be visualizing an effect sequence. So this involves a dark, foggy environment, and we have a magical butterfly emitting particles landing on some sort of evil arm, transforming it to something else. So the things you need to visualize, as a reminder, you need to visualize that dark, foggy environment. You have to visualize what a magical butterfly looks like. You have to, again, think about how you can generate magical particles from that butterfly. And then you want to visualize what the evil arm looks like, or that arm that the butterfly lands on looks like. And then you're going to have a look at ways you can create that magical transformation, and then what the new arm would look like. So, again, this is an example, but you probably want more particles, definitely for the butterfly for that. But again, you have a butterfly there. It lands on the arm, transforms the arm, and then creates a totally new um, arm. So basically, it's a process of transformation. So hopefully that particular direction is clear. Again, it's probably going to be around 20 seconds or even less, so maybe 15 to 20. But again, there's going to be, elements of effects there and simulations that you need to be able to implement. So, for this week, we're going to have a look at pyro simulations. So, pyro simulations are things that you're probably familiar with regards to smoke, fire, and similar types of effects. So, things like particles, you might be able to generate it using particle simulation, right? But things like fire, you don't necessarily see the particles for fire, and you don't necessarily see the particles for smoke. So you want a different way of simulating those elements here. Now, for a week 6 challenge, you're going to recreate something like this. So notice that you have a sphere there, and the sphere disintegrates. So some of it is emitting, well, the sphere is emitting smoke, but as it disintegrates, it's going to be emitting fire, and then it just slowly, disintegrate like that. So the way to do this is to use fluid simulation or pyro simulations, and we're going to discuss that here. Again, when I'm talking about pyro simulations, I'm usually talking about those explosion, those fire things, smoke things that you normally see. Okay, now that's very hard to do if you're doing things using particles, because again, particles, the problem with that is particles is primarily driven by collisions and forces, and simulate fire and things like smoke. It's just more complicated than that. It's not just as simple as moving particles around. So for example, something like fire, it's actually made up of, the interaction between things like, the fuel, things like temperature, things like, particle physics, things like, so it's a combination of different things working together and interacting with one another. So it's not as simple as basic particle simulation. So as I mentioned, things like this, right? There's a lot of things happening in a typical pyro simulation like this. So what's happening is there's, element of fuel. There's an element of temperature. So once the temperature gets hotter, the fuel starts combusting. So there's combustion as well. So all of those things aren't necessarily, easily manipulatable using particles. So you have to go through something like fluid simulations or something like pyro simulations to be able to create that effect. So again, I guess similar to stuff like that. So see, so almost impossible to do with just basic particles, because again, you have a lot of stuff interacting with one another. And Houdini is really good with this type of effects. Okay, so with that said, so at least you understand what particle simulations are. Okay, as I mentioned, it's not as simple because you have a lot of things interacting with one another. You have, let's say, the smoke interacting with heat, interacting with temperature. Fire, for example, you have combustion there. You have fuel interacting with temperature. It's interacting with the wind. It's interacting with, the internal forces. And then you have things like buoyancy and things like, fluidity that affects all of that stuff. Okay, so you get this nice, really complicated looking movement.
Now, the math behind this is not going to be covered in this class, obviously, but there's some serious mathematics involved and serious physics involved in calculating the movement of objects using, a fluid simulation, right? So again, we won't cover that, but I guess the big takeaway is there's a lot of things happening, a lot of things interacting when you have something like pyro simulations or, smoke simulations. Okay, so with that said, even if it's complicated, okay, so I mentioned that it's complicated, math wise, interaction wise, even if it's that complicated, we're still following the same four simple principles, okay? So number one, the principle of sourcing, right? Meaning we have to think about what object is actually emitting the particles, emitting the fire, okay? So same thing, controlling the movement. So how do we control the movement? This will include things like playing around with, the temperatures involved, playing around with, let's say, the physics and the velocities involved, and then having things combine and interact with one another. So again, we can also do that using collisions. We can also do that by introducing, I guess, forces. But again, a lot of this will be based off the interaction between the different elements within that fire simulation or pyro simulation. And lastly, we can control the look, because we can definitely make things, be we can have it look like a red flame, a blue flame, a green flame. We can have it really smoky. We can have it, really wispy. So we do have the ability to change the look of our simulation as well. And lastly, caching and rendering it out. Those are things that, are quite common in any form of simulation. So again, even if it's complicated, similar thing, right? Sourcing, controlling movement, controlling look, and caching. Okay, now let me just quickly, before we have a look at some of those stuff, let me just quickly explain, I guess, the difference between what we covered last week, which is particles, and what we're covering now, which is pyro. Okay, so as I mentioned, with particles, with regards to sourcing, you really just need points, meaning it's emitting points or particles, and those particles, you're manipulating it. Okay, now the difference is when you're dealing with pyro, you're not only emitting points, you're emitting things that will interact with one another. Meaning, you're going to emit things like density, fuel, temperature, all of that stuff. Sounds complicated, but again, you're not just emitting points. You're emitting, you're emitting different properties, different, different components for your simulation, right? So all of that will interact with one another. Now, for controlling movement, the difference with particles, we primarily control it using forces and the collisions. But as I mentioned, with pyro, it's really the interaction between the different, properties like heat, temperature, velocity, density. That's the key contributor for creating that nice fire effect or that nice smoke effect. Sounds complicated, but I'm just laying this out so everything we do will make sense. Now, controlling the look, the default option is particles. Basically, you're primarily working with particles, and particles are just points, right? So you can do stuff with it. But the thing with pyro, though, is you're now working primarily with volumes, so VDBs. So again, with particles, it's particles, points. Points, you can manipulate, copy points, all of that stuff. But with pyro, you're manipulating primarily or controlling the look of primarily volumes or VDBs. So other things will apply with volumes, right? You can deform the volume and you can manipulate the volume on top of that. But we'll talk about that later. Now, caching is pretty much the same. You still use the same file cache node, okay? So we'll cover two things now. We'll cover perhaps smoke, and then we'll cover fire, okay? So for smoke, guys, okay? You really just need, so in the context of Houdini, you really just need two things to be able to create smoke. You need density. So basically, that's the density of smoke. So basically, density is like, well, I guess you can just consider it smoke. It's the density of the, the volume involved. Okay, so it's how, basically how dense a smoke is. So you need that density to be able to create smoke. Okay. Sorry, not too sure what you mean by how compressed. I know, it's just the term density. Okay. Yes, how compressed it is, but it's really more if it has zero density, that means that there's no particles involved there. But if it has, let's say, a density of 1, it has a lot of particles or particulates there. So I'm calling it particles, but it's not necessarily particles. It's really just minute particulates that represent, let's say, a smoke. So again, it's I guess the amount of matter. Okay, so let's just call density as the amount of matter or smoke material you have in a volume. Okay, so again, we need density and we need velocity. Okay, that's right. So you can consider it thickness or transparency, although it's still different, but we can consider it that way. Okay, but with smoke, guys, you need two things, right? You need density. In fact, you really just need density, but you also need velocity. And the velocity is the one that will push the density or push the smoke in any particular direction. Color, you can actually introduce color, but the thing is we're using Karma XPU, which make it difficult for us to introduce a lot of color. So we're going to primarily concentrate on density and volume first. Okay, so as I mentioned, density and volume, and then again, we already know that it's all about sourcing, controlling movement, controlling look, and caching. Okay, so with that said, I'm opening Houdini and I'm setting up my project, right? So let's try something really simple. And then recent project, and then this one. Okay, so what I mean by, let's say, density and velocity. So what I'll do, guys, is I'm going to introduce a grid, okay? And a relatively straightforward grid, right? So you just have an object there and you have a grid. So we're going to introduce, or we're going to specify what is actually emitting our flame, or sorry, our smoke. So as I mentioned, it will be a process of specifying the source, but again, that source has to emit both both density and velocity, okay, to create smoke. So what I'm doing, guys, is perhaps I'm going to introduce a very simple node, okay? It's called the pyro source node, okay? So again, we're currently in geometry level. I'm just typing in pyro, and then I have pyro source there, okay? So this is a very simple way of introducing, the elements of density and velocity. So I'm plugging that in, okay? So notice what happens there, okay? We're plugging that in, and notice that it's basically just using the points of your grid as, I guess, an emitter for whatever it is we're trying to emit. Okay, so see, notice that it's just converting it to a series of points specified by your points there. Okay, because the current settings is set to initialize. But let me just change that to, let's say, instead of keep input, let me just change that. So it's initialize, keep input. You can just disregard that. For now, just have it initialize, but it's basically keeping your object, right? The points of your object. But what I'll do is I'll just scatter surface, okay? So notice what happens there. Now we're scattering points around it. So basically, it's basically just a scatter, right? We're just scattering points around it, and we can control the scattering based off this particle separation. See? I modify that, and then I have something like that, okay? So relatively straightforward stuff, okay? As I mentioned, you really just need two elements to be able to introduce smoke. Number one, you need density. So we're going to introduce the attribute of density. It's this one here, guys, under pyro smoke. Okay, so pyro source, we're introducing an attribute called density. Okay, so it is a point attribute. If you don't believe me, middle mouse click. See, it is a point attribute, guys. Okay, so basically every single point there that you have will have a density, and the density is specified by this value that you have here. So we just have that at 1. Okay, so relatively straightforward stuff, right? We're introducing density. Okay, and basically, if it has a density of 1, it will emit smoke. Okay, so it will provide or create an initial value for smoke. If it has a density of 0, then it won't be able to, I guess, emit or create smoke. So 0, no, 1, it will. Or anything above 1, it will. Okay, or even anything above 0, it will. So that makes sense, right? So relatively straightforward. But I also mentioned that we're going to introduce velocity. Okay, so to be able to create our simulation, we have to introduce another attribute. I'll please click plus, and then we're going to introduce velocity, which is this one. Okay, now take note what velocities you're getting though, because the default function or the default values here is 1 in x, 1 in y, 1 in z. Okay, meaning it's pointing at a really weird place, right? But that's fine. Okay, that's fine. It's pointing at a really weird place, but it's totally fine. Okay, so we're already done that. The thing is, guys, these are all just point attributes. Now, with point attributes, you can manipulate them, meaning you can add a noise function or maybe add an attribute adjust noise, right? So totally doable, right? You're able to do that. Okay. We'll explore that later on. We're just doing this on a very basic level. But our next thing, okay, so I mentioned that we specify the source. So we've done that. We already added an object that has both density and velocity attributes, okay? Now the thing is, guys, you won't be able to use it unless you convert those point attributes into VDBs or volumes. Because, again, when you're dealing with pyro or smoke, okay, you're basically asking the simulation to have things like density, temperature, velocities. You want them to interact with one another. Okay, to have them interact with one another, you have to convert those point attributes into volumes or VDBs. Let me just show you what I mean by that. So these are just point attributes. You won't be able to use them in a simulation unless you convert them into volumes or VDBs. And the way to do that, guys, is to use a simple node called volume. There's actually a lot of ways to do this, but for you guys, really simple for now. Okay, we're going to use volume rasterize and then rasterize attributes. And what that means is we're just converting point attributes into volumes. When I say volumes, VDBs, right? So just to prove my point, say plug it here, plug it there. Okay, so I'm just plugging that in. Okay, so notice what happens now. If I activate that, I get something like that. Okay, it's totally black. And again, what this does, it just converts your point attributes into volumes. Now, what are the point attributes that we want? Remember, to be able to create a simulation for smoke, we need density and we need velocity. Two things. So the thing we're trying to convert under our rasterized attributes, again, it's weird because you have a lot of volume rasterized stuff there. So you have volume rasterized, you have volume rasterized attributes, you have volume rasterized particles, volume rasterized points. Guys, it's this one that you want for now, okay? Rasterize attributes. Anyway, with that said, the attributes you want to rasterize or we want to convert into volume is number one, density, right? So we're converting the point density attribute into a VDB. Just to prove my point, if you middle mouse click, notice what you get. You get a VDB. Remember, that's a VDB, right? That's a volume, okay? If you didn't do that, again, notice what happens. Middle mouse click. Well, see, nothing there, okay? Nothing there because we didn't really specify an attribute to convert into a volume, okay? So now we're going to specify that again, density, okay? As I mentioned, we're also going to specify velocity, V. There's P scale there and even color really if you want, but it's really just those two that we need, okay? Now notice that there's other things here. You can control the particle size, and that's basically the size of those, I guess you can call that tiny emitters there. So I can make that small or I can make that big, okay? But for now, let's just have it at 1. The voxel size is important though, because that's the resolution of your VDBs. So again, if you want more detail, you want a small voxel size, but if you want really big, broad details, then you probably want a bigger voxel size. Now, obviously, the issue is if this is too small, it will eat up a lot of memory and a lot of resources. If it's too big, then you won't be able to get, some really detailed results. So it's always a balance, right? But for now, maybe I'm happy with that, okay? So notice what happens now. If I hit play, nothing happens. Nothing happens because we just converted that into volumes. So see, we have a velocity volume. We now have a density volume. Okay? Now to actually create our simulation, guys, or to actually make that interact with one another. All good, Jordan. So to actually make the two volumes. So the two volumes we created, density and velocity, they're not interacting with one another. To have them interact with one another, we actually need a pyro solver. So we need a solver similar to the pop solver to make the particles interact with one another. But this one, to make those volumes interact with one another, we need this pyro solver. So I'm just plugging that in. Okay? And notice what happens. If you click on the pyro solver and then perhaps hit play, notice now that we do have some interaction going. Okay? Notice that we have smoke going in a particular direction, I guess. Okay? So notice, guys, that it is giving us a particular direction. I'll just modify, let's say, the size of the voxel. You know what? 1 is fine. I'm getting good enough result there. But see, guys, notice what's happening there. You have smoke. interacting with your velocity, interacting with a pyrosolver to create that effect. Okay? So relatively straightforward stuff, right? So if you really think about it, this is basically this the creation of your grid, the creation of your pyro source node, and then rasterizing that is basically your sourcing, right? I'll just add that in, network box. This is basically your sourcing, guys. Okay? So you're sourcing or specifying the emitters, right? Or the thing that's emitting whatever it is, smoke or fire or anything. Okay? The pyro source is basically your, and I'll just add a network box there. Okay, so the pyro source is basically your movement. Okay, well, technically you can even modify the movement here, but for us, okay, we'll just call this movement. Okay, so notice now that we do have that one already. Okay, so it's looks nice and we have something there going. Okay, so is that relatively clear? That's a really basic. Now we haven't really controlled the look yet, and I guess we'll have a look at that later on. But is this two things relatively clear for everyone? Any questions before we continue? So relatively clear for everyone here? Clear? Okay, great. So we already have that, right? Now, let's just quickly look at why this is behaving the way it's behaving. It's behaving the way it's behaving, guys, because if you remember, under your pyro source, remember, we have density there. So why is everything emitting smoke? Everything is emitting smoke simply because if you have a look at your, there you go. So if you have a look at, I guess, I might need to just reset this viewport. There you go. Because if you have a look at your pyro source node, guys, basically what's happening is you assigned a density attribute there. See? And it's one for every single point we have there. So it's obvious why everything is emitting smoke, right? Because you just have everything at one with regards to its density. Why is it moving in a particular direction? It's moving in a particular direction because if you remember, our velocity is 1 in x, 1 in y, 1 in z. So basically, it's positive x going left to right, I think, and then positive y going up, and then going forward as well with positive z. And just to prove my point, if you don't believe me, okay, so see, it's moving that way, right? What happens is if I actually change this, let me have that at 0, 0, 0. And notice what happens, guys, okay? With 0, 0, 0, notice that it doesn't move at all, right? Primarily because you didn't give it any initial velocity. But let's give it an initial velocity of, let's say, 1 in y. And notice what happens if I hit play. Now I have something like that. See, it's just moving up, right? Again, this is in your pyro source, right? It's not in your pyro solver, it's in your pyro source. So if you think about it, you're controlling the object or you're controlling the movement in the pyro source as well. That's right, it looks like a mushroom. But again, it looks like you're manipulating the movement here. But technically, you're just specifying the initial velocities of those objects. Obviously, it's affecting the movement, but it's really just the initialization process there. Just to prove my point, zero that out, change that one in x, and notice now it will move in x, right? And that's because, again, it's 0 in y, 0 in z. Okay, so notice now that I have something like that. Okay, so relatively straightforward stuff, right? For now. Now, another question is, why is it behaving this way? Why you didn't assign anything? Why is it behaving in this nice fluid-like manner? And that's just the nature of fluid simulations, guys. So what this solver does is it'll try to recreate what a typical smoke or typical fluid will do given this scenario. So given a scenario where you have an object emitting smoke and it's giving you an initial velocity in, let's say, x, the solver itself is smart enough to understand that if this is a real object or this real smoke, it will probably behave something like this. Okay? Something like that. Now, it doesn't mean that it's not directable. It's directable a little bit. Okay? Simply by going to your pyro source node. Okay? Now, in your pyro source node, guys, there's a lot of things here that you probably want to, explore. There's start frame, so you can obviously specify when the simulation starts. And there's also things like voxel size. Okay, so obviously the smaller the voxel size, I guess the more detailed your simulation is, but it will increase your render, and it will eat up a lot of resources. So I'll just skip that for now. Skip this. I do want to control the movement of this. Okay, so to control the movement of this, I'll go to fields. Okay, and notice that you have things like dissipation and even other things like diffusion and all of that stuff. But for now, have a look at dissipation first, because if I zero that out, or maybe I'll increase it to something big, let's say, I don't know, 1, notice what happens. It dissipates immediately. You know what? It that's too much. But see, dissipation, I increased it by a significant value, and notice that it dies immediately. So it's almost like lifespan. Okay, so remember earlier it was like this, and I have that, but now I increased that, and I have that. Okay, so you're technically, again, it's weird because you're technically also modifying the look of it, but it's basically controlling the movement of it. I guess it's a combination of both. But again, that's fields, right? There's dissipation. That's probably really important, right? Knowing that dissipation, again, that's what it does, okay? For the dissipation there, okay? I'll just stop that. Let's have a look at another thing that can help you control the movement of this, or the look of this. Well, movement primarily. Have a look at shape, guys, okay? Because notice now you have buoyancy. And buoyancy, if you hover your mouse there, it's basically the force that's pushing it, I guess, going up or making it buoyant. So let's say I'll zero it out and then hit play. Notice what happens. I get something like that, okay? So even if I, for example, so if I increase this to, let's say, something like that. Notice that for, I guess for this one, see, maybe I'll just lower that. So again, buoyancy also changes the way it looks and changes the way it behaves. Okay, now there's a lot of other things here that you can introduce, and I guess let me just modify a few things here. Maybe under fields, I just lower down the dissipation because I think it's affecting it. So there you go. So see, guys, notice now that I can change perhaps the look, maybe modify, sorry, the shape, and maybe modify. I think it's not clear here unless we actually have a force going up. But again, this allows you to modify the look as well. On top of that, you can introduce things like wind. Not sure if this one will probably work, but let's see. So I can introduce wind, and I can also introduce a direction for that wind. So let's say I'll give a little bit of wind in, let's say, the y-axis, and let's see if that will work. Okay, so notice that we did give a little bit of wind in the y-axis. It's quite strong, so that's why it's giving you that particular look. Okay, so notice, guys, that I can lower that down, and notice what happens. So it's basically just a directional force in any particular direction here. So you can introduce that. You can also introduce things like disturbance, and basically with disturbance, you're just maybe increase that. You just hover your mouse there and it just disturbs, I guess, puts a little bit more noise on, I guess, the simulation there. So notice that you are getting a bit more noise there. That's also similar, I guess, to turbulence. Okay, so if you plug that in, notice that if you increase that, you're just adding a bit more turbulence in your simulation there. Okay, so it might be a combination of both there. Okay. So again, you are able to control, again, we don't have time to really talk about every single one of them. It's really just about experimentation at this stage. But just take note that to control the movement of that, you are able to modify it under your fields and also modify it under your shape. Okay? In fact, you know what? Let me just, that's actually fine. So I'll just use that. Okay? So is this relatively clear for everyone? Just checking. Again, it's just experimentation in terms of what disturbance does and what turbulence does. Again, some of it I explored. Viscosity, I think, will make it viscous. So if you increase the viscosity there, it'll make it really thick. So see, it doesn't even move. So you see, with viscosity 10, it doesn't barely moves at all. So, but if you increase that or lower that down, it will move a little bit. But see, notice now that it makes it thicker and it basically opposes any movement of it. Okay, so relatively straightforward stuff. Again, it's about experimentation at this stage. Okay, so we already know that, right? We have the idea of what sourcing is. We know that controlling it is basically going to the Pyro solver and then modifying things like fields, shapes, and all of that stuff. So that's good. Let's have a look at changing the look now. Okay, so we'll explore controlling the look. Now we do have limited options with regards to how we can modify the look for this one. So what I'll do is maybe lower down my options here and let me just adjust that. Okay, so maybe something like that. Okay, anyway, so now to control the look, meaning to change the color and all of that stuff, it's a combination of the shader and what you do here. But a really simple node, so I'll just separate this. You can actually do it here under look. But what I'll do, guys, is I'll just introduce another node just to make things easier. So you have the look as a separate thing. So there's something there called Pyro Bake. Okay, so Pyro Bake Volume. Plug that in. And if you plug that in there, what this essentially does, guys, is it allows you to control things like density. See, notice that you can make it dense. And then you can even change the smoke color to, let's say, green. Okay, so again, see that Pyro Bake Volume. You can even assign a material here, but I really just want to turn that off. Or you know what? You can turn it on, but you'd have to assign the correct material for it. But you have things like shadow density. And then you have things like, again, if you want to have it scatter or emit fire. Well, you can't really emit fire at this stage because you don't have temperature. But for now, guys, see, I'm able to increase the density. And that allows me to create some really nice, I guess, shadows there. To really see the shadows, you really have to have a light. So I'll just introduce a light there. And maybe a directional light. And maybe I'll rotate that directional light so you can see it. And rotate that so you can see it. And maybe I'll just increase that as well. Okay, so there you go, guys. Okay, so notice now that I have that particular look there. So again, for the look, introduce that Pyro Bake Volume, and you can modify things like density scale, shadow density, ambient shadow scale, but this one doesn't really do anything. And then basically, again, that's now your look. So I'll select that, add it, and then add look. So basically add a network box, and then that's our look. Okay. So does that make sense? But a really important thing here though, okay? The problem you have really when you do this is the Pyro solver actually emits volumes. Volumes are okay, but volumes are the old way of doing things. So it's a traditional volume. It's much better for you to actually convert that into VDBs. As I mentioned, VDBs is a more modern version of volumes. But as I mentioned, it doesn't automatically do it. Okay, you have to specify. Okay, so how do you do that? How do you convert this to VDBs, which is something you're familiar with? You know how to render it out, you know how to assign materials to it. So what I can do, guys, I can just go to my Pyro solver. This is basically part of look. I'll just convert that to VDBs. Okay, so there you go. So see, convert that to VDBs. So now you're converting. It doesn't really give you anything. Doesn't really change anything really, but what it does, it just converts your traditional volume or your old school volume, I guess, and convert that into a VDB, which is a new, more, I guess, advanced way of storing volumes. Okay, so I just converted there and then added that Pyro node. Now, if you're doing fire and flames, you might need to increase this significantly, or maybe just turn this on to actually get the fire. But we'll talk about that later on. Okay, but is this relatively clear for everyone? We already have, again, a couple of things there. Okay, so we have number one, sourcing. Okay, and we'll talk about that more as we move along. We have movement, and basically movement is just going and modifying the Pyro solver itself, right? And lastly, we have look, which is introducing that Pyro Bake volume so we can modify things like color and stuff like that. Okay, so relatively straightforward stuff. Our last thing, as I mentioned, last thing is to just cache it out, right? And render. This means adding a material as well. So what does this mean, guys? Okay, this means you introduce a file cache node, right? So that's caching. Okay, primarily because this eats up a lot of resources. Okay, so I'll just put in a file cache node, and then I won't really cache it, but you already know what it does anyway. So you just save to disk and then make sure to specify where you're saving it and then give it a name, right? So caching is important just to make sure that you're saving it to disk. Okay, I won't do it because I need to interactively change this, but that's the idea behind it, right? So basically, as I mentioned, I'll add another network box. And again, this bit is now for cache and render. Okay. Now, with that said, I normally prefer, so under bake volume, you can assign a material here, but I really usually prefer just adding a material after. So what I can do, guys, is I can add the material node, like so, plug that in, and I'm going to assign a material. So again, similar stuff. We don't have a material yet, so I have to go to the material palette, or in the material context. And remember, guys, we're dealing with VDBs, right? So we're dealing with VDBs. So what does it mean when you're dealing with VDBs? Okay, one thing that obviously everyone understands, right? So yes, you can render it as a fog or volume, but since it's a VDB, guys, see, you can easily do whatever you want with VDBs, right? Remember, you can go here and perhaps convert the VDB, okay? Basically, convert the VDBs into, I don't know, things like a polygon, okay? Now, you might need to adjust the ISO value, but notice that you are able to do that. So see, that's technically a polygon, okay? So notice now that it does that, okay? So if it's a polygon, then you can assign an actual material to it. Let's say a liquid material or maybe whatever material that you want, okay? So other things you can do, you can convert that into volume, right? Other things you can do is you can convert it to, I guess, you can convert it to other forms of VDBs, remember? So you can convert VDB, and then you can convert that into, let's say, I don't know, you can convert that into a VDB, but this time a SDF. Okay, so now you might need to modify this value. So see, now I have, I guess, something like that. So see, that is possible as well. Okay, and the reason for that is you can now start combining volumes if you want, and then do a merge and do a a union or a subtraction or intersection, stuff like that, right? So I'm going to leave that up to you. Okay, but as I mentioned, you can just assign a material directly on the volume itself. You just need to create a special material, and the material for this one, guys, if you're trying to render out a fog, it's called the XPU Pyro Preview. Now, when you're a bit more advanced, we can use different materials, and we use a different renderer like the Karma CPU. But if we're using hardware CPU, then this is really our only option for now. Okay, so I'll have that. I'll just rename this. I'll call that, I don't know, I'll call that smoke map, for example. Okay? Now, it has the same properties as the one we had. So it's really just doing it again, unfortunately. So what I'll have, guys, is I'll just assign the same material to that. So this material is, remember, the smoke map. And then I'll just go and see if I can render that one out. I'll go to my output, and then I'll just plug in a Karma renderer. And then with that Karma renderer, I'll specify XPU. And then perhaps I'll just Karma viewport. Maybe I'll introduce a camera first, otherwise it might crash. So introduce a camera, lock the camera, zoom out, and maybe I'll just perhaps view it this way. And then let's see what that looks like rendered out under output, Karma viewport. And then see, guys, so notice that I have it like that. Now we have a question. It's green, but it's not green here. And the reason for that is you just need to copy the settings that you have in the material itself. Now, some of you might ask, why can't I just do the color in the material? Yeah, technically you can, but if you're a bit more advanced and you're not using Karma GPU or Karma XPU, there's a lot of things you can do in the Pyro Bake node. For example, modifying the color and then changing the attributes there that you're not able to do in the material level. So I'm just telling you guys to practice this workflow. because if you're going to do a more advanced stuff later on the process, it's I guess more streamlined, because there's things in the shader that you won't be able to do. Like for example, if you want to connect colors, if you want to do other things with it, then you won't be able to do it in the shader. But anyway, this looks fine. I'm able to do that. But see, material, I'll just increase the shadow density, and notice that I'm increasing the shadow density, guys. See, it's now dense. I can increase, let's say, the shadow density as well, and notice that I have more shadows there. Or I can change the color, and maybe I'll make that green. Okay, and then there you go. Okay, so now I have, I guess, something like that. And with that done, notice that that's exactly what we have, right? We have the sourcing, we have the control, we specify the sourcing by creating our pyro source and then rasterizing the attributes. And then we control the movement by just modifying the object itself, the pyro solver itself. And then we control the look by introducing that pyro bake volume. And lastly, we just assign the material, cached it, and then rendered it out. Okay, so is the basic workflow clear for everyone relatively? So just checking if everyone has any issues. So just I guess quickly checking with everyone here from Zachary, Will, all the way to Blake. So relatively straightforward. Obviously, if it's as simple as that, then we don't have anything to worry about. But it's really just using your understanding of, attributes, guys, that will really help you a lot. So just to expand your idea, your knowledge in this, right? So just to prove my point, it's really just your understanding of attributes. Okay. So for example, let's go back to our grid, and then let's just turn this off. Okay. So going back to our grid, and maybe I'll just turn off there. Perfect. Okay. So going back to our grid. Okay. Yeah, that's right. So Pyro source node, you can definitely use that as a group. In fact, if you have a look, see, there is a group button there. You can even specify. Okay. So just an example, guys. Okay. With regards to sourcing, let's just expand your knowledge of sourcing. Let's see if I actually have that here. Okay. See, you can use the groups. Anyway, so your knowledge of sourcing. So just an example. The reason why you have, see, something like this is because you use scatter. And then you just scattered points around it, and then assigned a, and then converted that into volumes, right? But I can take it a step further, okay? I can actually do the density myself. So what does that mean, guys? Okay? So with this grid, okay? So with this grid, what I'll do is maybe, you know what? I'll do it myself. I can scatter some points, or let's see. Maybe I'll just do a remesh. Okay? Doesn't really matter. Okay? Just to show you. I can do a remesh, right? So I have more points to work with. Okay? So there you go. Now each of those points will have, so again, you have individual points there, and each of those points will have attributes, right? So what I can do, guys, is I can introduce a simple attribute adjust float. Remember, density is just a float, right? So what I'll do is I'll plug that in, and then I'll just call this density. Remember, we just want that to be called density, because if we're converting that into, let's say, a pyro source or a volume, it's going to look for that particular attribute. So see, I have density there, and then I can just assign, let's say, I don't know, a noise property, and then I can play around with that noise. So what happens is, if you have a look there, see, I have density, and it's basically varied there. The only issue you have, it's hard to visualize what that density is. So I'll just introduce for you guys a simple node. So there is something there called visualize attribute. It allows you to visualize any attribute. So again, visualize attribute. It just allows us to visualize an attribute, right? So I'll just connect that. And basically, if you have a look here under visualizers, what we're looking for is we're trying to visualize density, okay? And then the type of visualization we have is, maybe you can use, we can use this one, or we can change that into, I don't know, grayscale. And notice that, see guys, I have that as grayscale now. So what this is doing, is this visualize attribute doing, is you're just visualizing density. The reason why you want to visualize density is obviously because you can't see what's happening there, right? You don't know which has more density, which has less density. unless you manually look at the geometry spreadsheet, and that's actually impossible to do. I mean, I don't know where point 1 or point 20 is, so I really don't have any clue what it looks like. So that's why you want to visualize the attribute. So notice now this is totally visualized now, and maybe I think the highest point is 1. So what I'll do is I'll just change the visualized attribute there. Again, guys, under visualizers, we're visualizing the attribute density. Maximum is actually 1, right? So now I have a better look at the density attribute. Okay, so what I can do now, guys, is I can go back to our attribute adjust float, and then maybe I'll just specify, for example, the fractal. Maybe I'll just turn that none, and then perhaps I'll just change the element size, and then maybe I can even expand that, maybe play around with, let's say, that one, or maybe I can do, you know, stuff like that, right? And then I can even remap that so that I can really just concentrate on those areas, and then there you go. Okay, so see, guys, we're just visualizing. So again, this is what I'm getting. So basically, anything that's white will have a density of around 1. Anything that's black won't have any density at all. Okay, so what I can do now is I can just plug this. We don't need the visualizer. Oh, well, I'll just plug that in. We don't need the visualizer. I can now plug that into our pyro source. But in the pyro source, what I'll do is, rather than changing this into surface scatter, what I'll do is I'll actually keep the input. Okay, so I'm basically keeping the input, meaning I'm keeping the remesh, and what happens is I'm also keeping the attributes there. Okay, so basically the attributes density. So see, notice that I have density there. So what I can do now is I can now activate my volume rasterize node. Nothing special, right? Activate my volume rasterize node, and notice what happens, guys. It respected what I did with my density. Remember, our density is like that. I plugged in volume rasterize. It does respect my density. In fact, let me just, I think it's the particle size that's a bit too big. So maybe I'll just lower that down. And then maybe the voxel size, and increase. You know, I don't want to increase that because it will eat up a lot of my memory. So what I'll do is I'll just have it like that. Okay, but if you want to adjust it, totally fine, right? You can just go back here and maybe just adjust it like that. Okay, so let's see what happens now. Okay, so nothing happened. I mean, what I'll do is I'll just give it an initial velocity as well of, let's say, 1 in y, so you can see. So instead of x, I just have it have initial velocity in y, and let's see what that looks like with our pyrosolver. So I hit play, and notice what happens, guys. I get something like that. Okay, now the reason why I'm getting something like that is obvious, right? The reason is, if you have a look there, see, notice that it only has density in areas that we actually assigned using this attribute adjust float. Remember, we modified the density, and this is the visualization of it. So basically, anything that's white has a density of 1. Anything that's black has a density of 0. And what happens is we just plug that into our pyro source, but we kept the input, so meaning it's respecting the attributes that you have. And then lastly, under volume attributes there, it's just rasterizing. We didn't even do anything there. We might have modified the particle separation or then the particle scale so that we might have, so this one. So we might have, I guess, cleaner results. But see, guys, if I activate that, notice what happens now. I get something like that. Okay, so relatively straightforward stuff, I guess. Okay. Now, there's also other things you can do on top of this, okay? Because, again, you can manipulate the velocity as well. Meaning, guys, I can go under pyrosource and I can modify the velocity here. Or maybe I'll add some. The problem with velocities, it's just hard to manipulate them. Because it's easy with a float with density because you can just visualize what it looks like. But if it's like velocity, it's basically direction and speed, so it's hard to manipulate it. So I'll just show you an easy way of manipulating that, okay? I'm actually going to manipulate the velocity after the volume rasterize. So what I'll do is I'm going to introduce a special node. So I'm going to manipulate the velocity after I created my VDBs or volumes, okay? So what I'll do is I'm going to introduce a special node called volume velocity. Plug that in, okay? And basically this one, I'll introduce a curl noise, okay? So basically, we're just introducing a curl noise, and it modifies the VDBs themselves. You won't be able to see the attributes because VDBs don't really have point attributes, but just trust that you're modifying the velocities there. Okay, we can actually visualize that, but I won't cover how to do that. It's a bit more advanced and it makes things confusing now. But see, basically what I'm doing is I'm just modifying the velocities inside those VDBs. And notice what happens now. If I hit play, I'm able to create that type of effect. So we're introducing that curl noise. So see, it's a bit too much on our velocities, and now it's breaking up our so remember, without that, if I deactivate that, you're just getting a really straight line going up. But introducing that curl noise in the middle, maybe increasing or decreasing the swirl size, just introduce that randomness there. Okay, so now you get that. Now I'll take this a step further by perhaps just activating that. So see guys, I didn't cache it, but see, maybe I'll just increase the density so you could really see, and then the shadow density as well. Okay, so now I have something like that. Okay, so I'm able to introduce, again, I didn't do it. Let me just, I guess, really emphasize that, right? I could have done it. I could have modified the velocity here and adjusted, basically attribute adjust velocity. The problem is, as I mentioned, it's really hard to adjust velocity, right? Because it's basically pointing in different directions. It's a vector, and it's hard to manipulate the vector by just typing in. I mean, you can do it by coding or maybe using other nodes, but it's hard to do it in this, at this level. But there are nodes with volumes that allow you to manipulate it quite easily. And notice that we do have that volume velocity node there. Okay, so now I have that. So is this relatively clear for now? So again, what we're able to do is we're able to manipulate the sourcing of it. Okay, again guys, we're able to manipulate the sourcing of that. Okay, so there you go. So we'll probably just do 30 minutes more, and then we'll probably just leave it at that. Okay, so almost done, right? Well, not almost done, but covering a few things there. Okay, let's take your knowledge of movement a bit further. So maybe one thing that's probably, so see, as I mentioned, you can actually use groups as well. So for example, groups, let's see. So what I can do is I can introduce a group here. So what I'll do guys is maybe I'll just introduce a group. Okay, group, and then I'll introduce a group there. Okay, so group 1, and then maybe it's 4 points, and then I'll specify the parts of the group. You can do it using a bounding box, or you can use it, do it by selecting it. So I'll just select that for now, press enter. So that's part of the group there. Okay, so the thing is, if you go to your pyro source, as I mentioned, it does respect groups. I think it's called group 1. So maybe I'll just call, I don't know, group. So see guys, it does respect it. So see, now your pyro source only does it for that. You rasterize the attributes, volume source, and then you have, I guess you really have to start resimulating again, right? So see guys, notice that it only does it for whatever group we specify there. Okay, so now it's only doing it in that end. Yes, it's animatable, but I don't even recommend you do this. So there is a better node to do this. You can use what we call a pyro spread, where you can just spread it in a more, elegant manner. But yes, you can use the bounding box to create that group. But I guess I'll just cover spreading before you consider perhaps using a group. Okay, but anyway, we do have this one already. Okay, if I hit play, yikes, I specify the group there, remove that, there you go. Okay, so hopefully this is clear for everyone. I'll just take your knowledge of controlling a bit more. So we added a volume noise. We haven't actually. Let's just have a look at collisions first. Okay, so how do collisions work? So basically how collisions work, guys, is, let's just see. Notice that your pyro solver will have a collision object or collision input there. if you guys can see that. So there's a collision input. Now, you can plug that in, but I'll show you an easier way to do that. Under quick setups, guys, okay, if you select the pyrosolver, under quick setups, you can actually easily introduce a collision by just initializing it. So we're going to go here and set up an SDF collision because it prefers volumes. It prefers VDBs for the collision. So it's much easier for you to just set it up in the pyrosolver itself. So I'm going to, again, go to the pyrosolver, quick setup, and then we're going to add SDF collision. So plug that in, and notice what happens. We have this one. Basically, we have this convert polygons, and we lost everything here. That's because we just need to introduce our object, right? So going back here, we'll just introduce our object. Maybe the object we want is a sphere, okay? So sphere, I'll plug it in, okay? So maybe I'll make the sphere bigger. And maybe I'll reposition it somewhere there. And maybe higher. Okay, so that's our sphere there. And then make that bigger. And maybe lower that down. Jeez. Okay, there you go. Okay, so guys, this is our sphere, right? We introduce it here. You can easily import an object. If it's a separate object, you can just do a merge. But we'll merge, object merge, if you want that. But we'll talk about that later on. But anyway, I'll just connect that there. So see, we just convert that into a VDB first. Because again, your Spyro simulation prefers VDBs or volumes. That's why we're converting it first. And then, once you've done that, see guys, notice what happens. You do get the collisions there. So see, notice what happens there. It's not as clear, but see, can you guys see that collision? So see, you don't have, maybe I'll increase it so you could really see it. So maybe this one, see, it's actually colliding. But what I'll do is I'll even make that bigger. So maybe there, and maybe there. And then maybe lower that down a little bit, okay? So just to prove my point, right? If I hit play, notice that it does collide. So see guys, notice that it does collide, right? We're only getting it here primarily because, see, our object is there. So if you want to see, I guess I'll just do a quick merge between that and this. So see guys, notice now that it does collide, okay? So is that relatively clear how to do the collisions? Relatively straightforward. So, the challenge does not need collisions, so I think you're fine. So again, the challenge doesn't really need collisions. So I think you're fine, right? But again, it's just good to know how to actually do the collisions, okay? Now, as I mentioned, right, there might be instances where the object is in a separate area, meaning you have, let's say, a rubber toy there, and then maybe I'll make that rubber toy bigger, and maybe I'll just reposition that, I guess, higher, right? So maybe translate, and maybe translate in here, okay? So see guys, now you have something like that. So for example, if you want that as a collider, all you need to do is go back here. Remember, I'll just remove that. As I mentioned, all you need to do is just do an object merge. So object merge. So object merge, right? And with that object merge, you can specify where that object is. So I'm just looking for the object, and that's basically our, I don't know, that's test geometry. There you go. Okay, accept. And then there you go. See, notice that, again, I'll just convert that. And notice now that, again, we introduced that object in our simulation there. Okay, so if I hit play, it will interact with that object, although it might not be clear there. But see, notice that it's actually clear. See, so notice that it's actually colliding here in the middle. Okay, so again, it's just an object merge. So almost done, right? We'll just cover a few more nodes or few more techniques with regards to controlling the movement. But let me just explain why this is important very quickly. So we don't really need that. So the fact that they're VDBs, guys, offer a lot of possibilities, right? So just to show you. So what we can do is we can introduce volume noises. Remember, in the previous assessment, you guys used things like volume noise fog or volume. I think I forgot what's the other one. I think we primarily use volume noise SDF and a volume noise fog. But see, guys, it's not really controlling the behavior. Sorry, the movement is more of controlling the look. So what I can do is I can introduce it after the look. So see, notice now that I can introduce things like, I don't know, a Perlin noise. We're introducing density, and then maybe I'll just go multiply, and then, so see, so I'm able to add that in, and then I can even animate the noise. So I think I might need to just increase this. You know what? Let's try subtract, or maybe let's try multiply. But we probably need this to be negative. Anyway, so you are able to introduce other things on top of that because they're primarily VDBs, right? So I guess that's the main takeaway there. So I think that's it. There you go. So we can look at retiming, but you know what? I'll just skip that for now. Okay. So 30 more minutes. Let's just talk about fire. So any questions with regards to smoke? So big takeaway for smoke, you really just need two things, right? You just need density and you just need velocity. If you have density and velocity, you should be able to create smoke. So any questions before we look into fire? So Zachary all the way to Blake. So no questions with regards to fire. Sorry, smoke. Heavy smoke, yes. So heavy smoke is just increasing the look of it, right? So this one, increase the density scale to something really big, let's say 200, and now you have really heavy smoke. Okay? So again, it's more of a density thing. Now notice that the detail is not very clean, and that's simply because in your pyrosolver and your volume rasterize attribute, you just need a smaller voxel size. Let's say 0.0, I don't know, 5. But just be careful, right? Because it will eat up a lot of resources. So maybe this one, 0.05. But you need to resimulate that. But see, guys, notice now you just have a cleaner looking, I guess, a cleaner, the density is probably a bit too much. But see, you just have a more detailed smoke there. Okay, it's not even smoke really. Okay. Okay. Yep. So, not quite sure what you mean by dry ice. Okay. Okay. So, basically, with dry ice, if you think about it, right? So, maybe what you might want in your pyrosolver is you might want to increase or decrease the buoyancy for that. So, it just go down. You might introduce a wind that's going down. So, and then you might introduce a few other things, perhaps introduce some for some viscosity there. Okay. So maybe I'll just have this wind and maybe negative 0.2. And then let's see what that looks like. And again, we might need to adjust a few more things. And then maybe increase the viscosity. Obviously, again, it's about experimentation at this stage. I'll just bring this back. And then maybe I'll just adjust this one as well. So once you experiment with things, you should be able to get that. Again, you just really need it to go down, right? What I'll even do is maybe I'll introduce a force or maybe an object on top of it, so it'll just push it down. Or you can do that using the wind, or you might introduce things like viscosity, or maybe adjust a few more other things there. Okay, so a little bit of experimentation, I guess. So guys, at this stage, let's just have a look at fire. Because for fire, you need a few things, okay? Fire, guys, exactly the same thing, okay? With fire, exactly the same thing. You need, again, sourcing, controlling movement, controlling look, but you need to introduce a couple of other things. To create fire, you just need two elements. You need temperature, which specifies which areas will catch fire. And you need burn. Burn is a bit tricky because in the past we used fuel. The latest version of Houdini prefers using burn. So again, that's a problem. I guess it's not a problem, but that's the thing with any 3D software. It changes, right? So maybe 2 years ago, you'll use fuel, you use other things. But the latest version of Houdini prefers you to just use burn. So basically for us, burn is almost like fuel. Okay? So if you understand, I guess, the triangle of fire, for example. Okay? So remember, you get fire and you get different types of fire because of the effects of fuel, heat, which is basically temperature for us, and then oxygen, okay? Which is, you can call that, I guess, a little bit of velocity, little bit of wind as well. But you need those three things to be able to create fire, okay? And to create different forms of fire. For us, we really just need velocity as well, so we can consider oxygen as velocity in this particular instance. But really, guys, we just need temperature and we just need burn. Okay, so let me show you what I mean by that. Okay, so maybe I'll just create another object. Okay, so maybe this time I'll use a sphere. Okay, so as I mentioned, you need a couple of things, right? Number one, you need another pyro source. Okay, plug that in. If you guys remember, we need number one, temperature. Okay, so again, temperature. We'll give it a default value of 1. Basically, it means that it's hot. Okay, for all the points that we specify there. Okay, now what I'll do is I'll just scatter surface. And again, basically, every single point there will have the same temperature. Okay, and then I'm going to introduce another one, which is, again, burn. So I'll just click plus and I'll just look for burn. There you go. Okay. Again, there's fuel there, but again, guys, the latest version just prefers you to just use burn. Okay. So maybe this one, I'll just modify that a little bit lower. Okay. Again, similar stuff. Okay. This is basically your source. Okay. Now on top of your source, remember, we're going to rasterize the attributes. Remember, guys, it's volume. So rasterize. So volume, rasterize attributes, right? Plug that in. Remember, the attributes we're rasterizing or converting into a volume is going to be temperature and it's going to be burn. Okay? So we already have the sourcing done. Okay? So that's add network box and basically that's your source. Okay? So as I mentioned, you just need temperature and you just need burn. So burn, you can consider that to be your fuel. Temperature is basically the matchstick. Okay? So what happens now is we convert that into volumes. And that's exactly what we have. We have a burn volume. We have a temperature volume. Then we plug that into a pyro source node. Okay. Plug that in. Sorry, not source. Geez. It's pyro solver, right? To calculate the interaction between those two things. And notice what happens, guys. We automatically get fire. Okay. So what I'll do is I'll hit play. And if you hit play, notice that we do automatically get fire there. In fact, it's a bit too much, right? So notice now that, again, we get that fire because all of the single points there is emitting. It has a really high temperature. And then everything also has burn or fuel in it. That's why we're creating that fire there. Okay? Now, you can modify the fire by perhaps, again, changing a few things here. I'll go to fields. And again, this is really just stuff that we covered, right? So for example, if you increase, let's say, dissipation, then it will dissipate immediately. Okay. And notice that there's temperature there. Now you can increase the cooling rate. The thing is, it won't probably decrease it. It probably won't change it too much, primarily because you're continuously emitting fuel there and temperature. That's why this probably won't change. You know what? It actually changed a little bit. So I'll just increase the cooling rate to 1 and notice now that I get a totally different look. So remember, cooling rate that. Notice that it takes a long time to cool and then it giving you a longer flame. But now if I change that, now it automatically, well, it makes the cooling process faster. So now you get a much smaller flame. Dissipation, I think, looks like it doesn't work with dissipation. You just get that. Okay, but I think what this allows you to do though is you can emit from flame, meaning you can actually emit some density out of the flame. And maybe I'll just increase that. So see guys, notice now that we have a little bit of density, but we'll just skip this for now, okay? We'll just concentrate on, let's say, the shape, because notice that we have buoyancy now. And basically it's the force that pushes it up, but we can make that smaller. Okay, so notice now that there's less force, and now it's actually just hovering in that area there. So what I'll do, not sure if we can make that negative, and say, see, with negative buoyancy, now it actually goes down. So maybe negative 0.1. And let's see what that looks like. Okay, so now I have something like that. So again, it's the force that pushes it, right? Outwards. So now I have, I guess, something like that there. We can introduce wind as well. You guys already know that. And basically the wind is going in the x-axis. And then we can introduce disturbance as well. And basically, if you hover your mouse there, disturbance is introduces random forces to the simulation to add higher frequency detail. So maybe I'll increase that and let's see what that looks like. You see, notice that you're getting more, I guess, details on the edges. See, guys? So if I turn that off, it's smooth. But if you turn disturbance, now you have a bit more detail along the edges there. Now, the level of detail will be dependent on your voxel size. So if you have, let's say, smaller voxels, then you probably get better looking detail there. Okay, so see guys, notice now that I get better looking detail. Almost done, because again, I'm not a big fan of explaining every single one of them. Can I trust you guys to just have a look at that and then play around with it yourself? Meaning, have a look at what shredding does. Have a look at what flame expansion does. Have a look at viscosity. Otherwise, we'll just spend the rest of the class just talking about individual, parameters, right? Without any experimentation at all. Okay, so with that said, so all good. So how do we control the look? Okay, so this is basically the movement. So let me just add that in. And then let's just add movement. Okay. Again, I won't talk about what you can do here because obviously you can play around with temperature. You can play around with burn, but I'm going to leave it up to you guys to experiment. But for now, see, that's movement. And then as I mentioned, the pyro bake node is really useful for this type of stuff. So pyro bake volume, plug that in. Because in the pyro bake volume, guys, notice that we lose the fire, and that's because in the fire here, we actually have that off. Activate that, and we can change things like color, we can change things like intensity, and then you can even use a ramp, but it's not really applicable for the XPU Pyro Preview, so I'll leave it at that for now. Secondary fire doesn't really work, so you don't even, well, it can work, and we'll have a look at that later on, but basically secondary fire, you have to plug in a different attribute there. So currently we don't have that attribute, but for now, see, I'll just activate fire. You do have the intensity there, but you can also compute the range if you want. Okay, so that's useful for modifying the intensity of that. So see, I can make it start really hot, or I can even change the color, maybe have that blue, and then become red, right? So now I have, I guess, something like that. Okay, and now you can also do other things on top of that. Okay, so that's the look, guys. Pyrobake volume, and then remember we do a file cache, and then we do a material, right? So this is rendering, so this is look. Well, technically this can also be look and rendering, really, but for now I prefer that you guys just have that in mind, because there's a lot of things you can do there when you have an advanced renderer. Currently, we don't really have an advanced renderer, so we're limited. But for now, see, I have that. And this is my look. So this is look. And then lastly, guys, this is caching and rendering. Okay, and then plug that in. And then obviously like that. So again, for the rendering part, remember, just make sure under material, you create a pyro preview. So again, XPU, pyro preview, plug that in, and this is going to be my matte for my fire. Remember guys, by default, the fire is usually set to 0. So you might need to increase that and then play around with other things there. And then if you go here, so see, that's the problem you have, material guys. See, we have limited options. We just have fire color there. We can't really control, we can't use a ramp to control the fire, but this one we can. So see, notice that we can with the pyro bake volume. Okay, so this material, we just add that in. So with that's matte fire, and that's pretty much it. Okay, so does that make sense for everyone in terms of just a simple setup for fire? Okay, so you really just need burn and you just need temperature, right? So if you have temperature and you have burn, you're able to create that effect. Okay, perfect. Okay, so let's just take this a step further. Okay, so one last topic before we wrap up. Okay, because again, I won't cover all of the stuff there because it's basically the same. You already know, if you know the system, then you know where to go in terms of modifying the look, modifying the source, and modifying the object, okay? But there is probably something there that that is probably harder to do, and that's spreading fire, okay? So let me just explain what fire spreading is, because we're going to introduce something that we haven't covered, I guess, in the past. So let me just create, let's say, a simple grid, okay? And let me just remesh this. And then maybe I'll just introduce, maybe lower down the target size. There you go. Okay. So anyway, guys, you have pyro source, right? Which is good. But there's also another way for you to create a pyro source, okay? And that is through another special node called pyro spread. So basically, pyro spread is a form of pyro source. So it allows you to create a source of, so remember the pyro source, we are able to convert those points into, you know, attributes we can use for our volumes, to convert to volumes. It's actually quite similar, but this allows you to spread things on top of that. So look for pyro source spread, okay? So notice what happens. I'll plug that in, okay? What this allows you to do, guys, this particular node, is allows you to spread any attribute that you want. The attribute that I'm particularly interested with is temperature, okay? Because I can spread that out. What this means, guys, is I can introduce, let's say, a point here, okay? So what I'll do is I'm going to perhaps create a point using, or create an attribute. So maybe I'll create an attribute. I'll do an attribute create. You know what? There you go. So I'm going to create an attribute. I'm going to call this attribute temperature because, again, that's the one I want to spread out. So what I'll do is I'll create that first. And then basically what that does, it assigns a temperature for all of them. Okay. The temperature is the value of 0. Okay. You can actually see that here. If I change it to 1, now it will give it a temperature of 1. But the thing is, I don't want everything to be 1. I just want certain areas to be 1. Okay, so what I'll do is I'm going to introduce a group before that, and I'll plug the group here. So let me just show you what I mean. So I'm going to create a group, okay? The group doesn't really matter where. So for example, this one, I can select, let's say, this points here as part of the group. So what I'll do is I'm going to click on this group and then specify, let's say, these points here, okay? And press enter. So again, we're just selecting those points there as part of the group. So I'll just make sure that's a point group. There you go. And again, see? So we'll do that one more time, okay? Because I didn't specify it to be a points group. So I'll just specify that to be a points group. I'll select that, and then I'll select that here, okay? And then there's our point group. So again, we created the point group. We just assigned those elements or those points in the middle as the points that are part of the group. And then in our temperature, guys, what I'll do is I'm going to specify that group, okay? Now, what happens is really something special, right? It's basically assigning 0 on everything except the ones that you selected, Okay, so let's have a look. So look, notice guys, see, the points that are part of the group, there it's giving it a temperature of 1. You can actually see that, right? But the points that are not part of the group, it's giving it a value of 0. And the reason for that is when you create this attribute create, again, the default is 0, but the value of 1 is added on all the objects or all the points assigned to that group. Okay? So again, everything else is 0, but this one is 1. Why is this important? Because we can spread that. It doesn't even have to be temperature really. Just to prove my point, with this pyro spread node, guys, notice that there's temperature there. I'll activate that. Okay? Notice that with activation, what I'll do is perhaps, again, it reads the temperature. So I'll just go there. See, guys, notice that it actually reads the temperature there. It gives you a visualization of what's happening, right? So meaning this has a cool temperature, while this is relatively hot. Okay? Now, I can modify that by just adjusting the cooling rate. Notice now, adjusting the cooling rate allows me to specify that this is really hot and then the rest is cold. But the special thing here is if I hit play, notice that it can actually spread. It's not spreading because we just need to increase the rate. Or maybe modify the cooling rate, I think. So let's try that one out. Temperature. Let's increase the search distance. Okay, so it's not giving us the correct result because we don't have enough distance between the points to spread it out. So maybe what you can do is you can increase, let's say, decrease the target size to, let's say, 0.08. Okay, so you have more points to work with. Or you can just adjust the search radius. Okay, so there you go. Okay, and then modify this a little bit. And then let's see what that looks like. Okay, so if I hit play, notice what happens. I get that. Okay, so what happens is technically, guys, okay, so I'll just turn this on, hit play. Maybe I'll change this to, let's say, 150 or 100. Okay, so there you go. So notice now that I'm getting something like that. Okay, now there's a lot of things you can do. So basically, you're just visualizing it, right? You're visualizing temperature and the spreading of temperature. Okay, it's not giving you a color. Okay, you're just visualizing it, so it's not technically giving you a color, right? It's just giving you temperature. Okay, so see, there's no CD attribute there. It's just visualizing it, but what's spreading is temperature. Okay, and if you don't believe me, have a look at your temperature there. So see, fuel is changing, but we don't really need fuel. The more important thing here is temperature is changing and total burn is changing as well. Okay, so what does this mean, guys? Okay, what this means is now we can rasterize these attributes. Okay, I'll turn this back to none. Okay, so we don't actually see the red thing there, but take note that it's still giving you that spread. Okay, so what I'll do, guys, is I'll just change this to none, and then I'll just rasterize the attributes again. Remember, we rasterize the attribute by introducing the volume rasterize attributes. Plug that in, connect, and then what I'll do is, again, attributes we're rasterizing. Remember, it's fire. It's going to be temperature. It's going to be fuel. Sorry, not fuel. Jeez, burn. Right? So, burn. Okay? So once we have that, guys, notice that you're not really seeing anything there. You're seeing some spread, but you obviously need to introduce a pyro solver, right? So to actually see what's happening there. So I'll plug in pyro solver there, and notice what happens. That's exactly what we're getting. Okay? So if I hit play, notice now that we get the flame spreading out. Okay? A bit too much, so what I'll do is perhaps modify a few things here. So what I'll do perhaps, guys, again, this is a bit too much, so what I'll do is perhaps go down to my shape, lower down the buoyancy a little bit, maybe under fields, increase the dissipation, maybe increase the cooling rate, and then perhaps I think we introduced a bit of viscosity. And let's see what that looks like. If I hit play, I guess I have something like that. And I think that was cooling rate, right? That really allowed us to modify it significantly. So let's try cooling rate. Or you know what? Maybe we can just make this grid significantly bigger. So maybe I'll just increase that to, I don't know, 20 and 20. And let's see what that actually looks like. Going to our pyro source. temperature. Again, going back in, I might have, I'll just select those bits. There you go. Then temperature, and then pyro spread. Okay, and if I hit play, I get something like that. Okay, great. So again, rasterize node, and then pyro solver, right? So if I hit play, now I have something like that. A bit too much, so what I'll do is I'll just go again here under look. Okay, maybe I'll just add a pyro bake volume because it's a bit too much. So what I'll do is I'll go to fire, activate that, lower the intensity scale, and maybe compute the range. And maybe make that significantly smaller. So there you go, guys. And then I'll hit play. Okay, so now I guess I have something like that. Okay. Now I think we're not getting, if I go here, so see, notice that I might have increased it too low. But see, guys, we do have something like that already. Okay, so what I can do in the pyro solver itself, it might be just a case of increasing the cooling rate. So something smaller, or maybe increase the buoyancy. Maybe introduce viscosity. And maybe I'll even go here under rasterize attributes, and then maybe lower down our voxel size. So we have something smaller, maybe 0.05. Okay. So what I'll do is, let's see, with our pyro spread, I'll go here, rasterize attributes. I might lower down the particle scale because it's just too big. So maybe that gives me a better looking display there. So see, guys, if I hit play, now I have something like that. Okay. Now a bit too much. So what I'll do is maybe I'll actually modify again. Again, this is where you were just experimenting with things, right? Because I modified the point size. I might need to go back to my fields and perhaps lower down our span under sourcing, sorry, under shape. We might need to increase our viscosity and then lower down our cooling rate a little bit. And let's see what that looks like. So see, guys, notice now that I'm getting something like that. Okay. Now, if this is annoying you, there is a look there that you can just modify. So that basically with the fire intensity, you can just have that lower, right? So what I'll do is I'll just have that play. And now I guess I have something like that. So it is spreading, right? So notice now that it is spreading. Now, if you want to modify the rate of its spread, so here, so see, maybe it's going too fast. So what you can do is you can modify the spread itself. So again, under temperature change, maybe I'll increase the cooling or decrease the cooling rate. And then let's see what that looks like. Maybe I'll really decrease that significantly. Okay, and then hit play. So there you go. Looks like that's definitely slower, and that might give me a better looking result. So let's see, guys, if I hit play, and I have something like that. Okay. So is this, again, lots of things here that I can probably modify. For example, I'm not a big fan of the amount of fire that is producing there. So again, it's really just going here and perhaps modifying the fields, like increasing the cooling rate, and maybe change this to a smaller buoyancy or introduce a bit more viscosity. And then it will allow us to create whatever it is, I guess, that we want here. Okay. But again, going back here, remember, right? What we're essentially doing is we're using, instead of using the pyro source, we're using pyro spread. And basically the pyro spread creates not only burn, but it can also create temperature. Okay? Now what we did though is we introduced temperature, because if you don't introduce it, Houdini doesn't know which points are, of which temperature. So what I did was I just added a temperature attribute create node that allows me to specify which points are going to have an initial temperature of 1 so that it can start spreading. And that's exactly what's happening there. See? So notice now we have this area set to 1, and then we have this area. So see, specified by the group. We now have that spreading. Okay, and then we adjusted basically our pyro spread. Okay, so I guess is the process clear for everyone at this stage? Any questions with regard to this one? So the pyro spread allows us to create that spreading effect. The only difference is you just need to specify which areas are going to have that initial high temperature. Okay, you can actually use any attribute for this, but it's the temperature that's really interesting for me, right? So what I did was I added a attribute create. That attribute create basically specifies that anything in that group will have a value of 1. So that's why I created this group, and that group is basically includes just the middle points here. Okay, so once I have that, I can plug that into this pyro spread, and basically it's spreading their object there. Okay, now it doesn't even have to be in the middle. The beauty behind that and why this is better than grouping is because it doesn't have to be in the middle. It can be, somewhere totally different. You can have it starting here, or you know what, just to prove my point, guys, okay, just to prove to you how interesting this is, you see I can select that, and I guess, see, those things. So now it doesn't only start there, it also starts in the corners. So looks like I have some issues with my mouse. Very quickly. So mouse issue, sorry everyone. There you go. So anyway, going back to our pyro spread. So again, specify the group, that one, and maybe this one. Press enter. So hopefully that worked. So still nothing. So you know what? Let me just delete that. So select the points again. That one. Just to prove my point, right? That one and that one. A bit tricky to select. Press enter. And then there you go. Okay. So now you have that attribute create. And then you have that pyro spread node. So as I mentioned, with that pyro spread node, see, we now do it in not only the corners and not only the middle, but also the corners, right? And now if we convert that to a pyro spread, notice now, just turn it off. And then if you have a look at our pyro solver, I have something like that. So it takes time to simulate, but you are getting some really good results there. Okay. Now let me just. I guess it's full of. I guess we might just spend just a few minutes with regards to this one, right? Because there's really a lot of things you can do with the pyro spread node, guys. Okay. Because as I mentioned, this is just a visualization, right? You're supposed to put this back to none. Okay. Now what you can do now is see with this particular knowledge, right? Again, it doesn't necessarily have CD, right? So notice that it doesn't have CD. But with this knowledge, you can do a lot of things, okay? Number one, you can obviously add an attribute adjust color, okay? So basically, attribute adjust color, plug that in, connect that, okay? And remember, I can perhaps remap an attribute, and perhaps I'll remap it based off temperature. And notice what happens, maybe instead of red, I'll have it at, so instead of red, maybe, you know what, let's have it yellow, and then maybe it goes to green, and maybe it goes to blue. Okay, so let's see what that looks like. Again, I'll just compute the range, and now let's see what that looks like here. Okay, so now I have something like that. Okay, I'll just again compute the range to see if I'm getting a better looking result. I'll just go all the way to the end and maybe compute the range there, and let's see if that actually gives us a better looking result. So see guys, notice now that I have something like that. Okay, so again, interesting stuff, right? With regards to, but on top of that, you can even do that. That's color. So what you can do, you can even introduce that to, let's say, attribute adjust float. Okay, and maybe with that attribute adjust float, I can plug that into, I don't know, remap attribute. Let's plug in temperature. And then let's connect that to p-scale. So remember, I can use a copy to points. And then again, those are the points I want to use. And then maybe I'll use a cube. And then let's see what that looks like. Okay, plug that in. And we might need to just reverse this. Okay, so notice what happens, guys. There you go. So see, if I hit play, now I have something like that. Okay. Again, primarily because we're just grabbing the temperature and the temperature is spreading. So if we remap that to other attributes, let's say p-scale or something else, then we're able to create some really interesting effects, right? So it's basically, there's a terminology there. It's progression. It's infection, I think. Okay, so it's infecting everything around it, and now you're creating that effect. Now take this one step further. Okay, so take this one step further, and instead of p-scale, I'll just call this del me, for example. So delete me, and then I'll just compute the range for that. So it's basically putting it 0 to 1. And what I'll do is I'll just blast, or maybe I'll just group. So I'm going to group everything. So basically at del me, so I totally forgot, del me, it's capital M. Doesn't really matter, right? Whatever you put there. If it's greater than 0.5, plug that into this group. Okay? So let's see if this actually works. I'll make that a primitive group, and let's see if this actually works. Temperature, compute the range. So maybe here, compute the range. Okay, so maybe, so del me greater than 0.5. Let's see if that works. So I'll just remove group 4. So maybe perhaps this one didn't work. But again, I can even just use this really. So that's CD. So that's green. So what I can do is, let's see, maybe I'll just use red. So you could really see, guys, let me just change this to red. So maybe change that to red. And then maybe change this. Maybe I'll just remove that. So maybe something like that. Okay, so there you go. Okay, so what I can do is I can even manipulate that. So maybe it's red there. Okay. So see guys, maybe I have something like that. And notice what happens there. I'm getting something like that. Okay. And what I can do is maybe I'll delete everything that's red. Meaning I'll group everything. So group. And maybe I'll make this a point group. And I'll just call this at cd dot r greater than point, I don't know, greater than 0.6 or 0.3. I want to plug that into that group. So it's going to be points. This one is also points. Plug that to that group. So there you go. So see guys, notice that I plugged everything that is greater than 0.3 in that group. And what I'll do is I'm going to blast it. Okay, so let's just blast that. So blast everything that's in group 2. Okay, so notice what happens. Basically, I grouped everything with a red component greater than 0.5. And what happens is it only leaves out the blue areas. And what happens is if I hit play, I get something like that, right? Now I can even take this a step further. I can make that obviously my pyro source if I want to. So pyro source. So it's my new pyro source. And remember guys, we really just need temperature. And we need, let's say, burn. And then we rasterize the attributes. Okay, so once we rasterize the attributes of burn and temperature, we can now plug that into a pyro solver. And then let's see what that looks like. Okay, so see, notice what happens, guys. Plug that into a pyro solver, and now I have something like that. Okay, so notice that it spreads, but it also gives you a hole. But if you just, for example, adjust the cooling rate, so let me just adjust, I guess, the cooling rate for this. Or you know what? Instead of using the pyro source, just to show you guys, maybe instead of doing temperature, because you just need to manipulate that, but it is giving me what I want. It's just, it's a bit too bright. So maybe I'll just go here under look and then just modify that. So see guys, notice that I am getting that line. If I hit play, see, I'm getting that line there. Okay. So it's giving me that nice spread. Okay. So just to prove my point, right? So I basically have this one, okay? And it's spreading points. So what I can do is maybe I'll just use, instead of temperature, let's try density and let's try velocity. And then give it a velocity of 1 and then rasterize the attributes. But this time we're rasterizing not the burn, not the temperature, but the density and the velocity as well. So V. Okay, and let's see what that looks like. Okay, so going back, hit play. Notice now that I have something like that. So notice that, yes, it does give you that nice, I guess, line for the, for the smoke. Okay, and then there you go. Again, it's really just expanding what we know, right? It's just expanding the fact that we have that pyro spread and we know that it can spread out stuff. So what I did was I just used the temperature that's spreading, manipulated the color using this attribute adjust node. So I'll just go back to primitive. So see, I just used that using the attribute adjust node. So I'll have blue there. And then I basically just grouped everything that is primarily red. And then I just deleted it. Okay, so now I have something like that. Okay, so now I have something like this. Okay, so again, see, grouped it and then deleted everything that's red. And now I have that particular effect, converted that to a pyro source, rasterized it, and then created a simulation out of that. Okay, and then there you go.
So for our week 6 challenge, you're going to be recreating this sequence. So again, that's a sphere, and the sphere is emitting some sort of smoke. Now you don't have to recreate the specific smoke, you just come up with your own version of the smoke. But the fire is consuming that sphere. That's why you see it disintegrating, and then you have the fire coming from that disintegrated sphere. So to do this, you have to use the techniques we've covered in this particular recording, and then combine that to create different effects. Now, the thing is, you don't have to have everything in one simulation, right? You can just have that in multiple objects, or you can just have different, I guess, different pyro simulations either within the object itself, or maybe have that as different object level effects. So let's see what you can come up with this one. Now, I'm going to share this in Microsoft Teams, but again, looking forward to seeing what you're able to accomplish.